let's say, configuration, where, let's say, we are based on formal sensor descriptions, the openness, the reconfigurability, and all these, let's say, requirements can be found in let's say, the sensor ML type of, let's say, platform. So the standard for the sensor description could have the identification of the sensor nodes, the sensor capabilities, i.e. what are the resolution capabilities, the reach, the accuracy, the sensor inputs, the outputs, the processes, and the, let's say, connections. So all these have, let's say, to be more or less compiled and put in an information type of let's say, system. So this is for let's say, example, the document schema that is let's say, used for describing exactly the sensor, let's say, characteristics. And the paradigm here can show you that what I say we're building is that we have the sensors, we have the sensor modules, the mobile unit modules, and of course we have the, let's say, medical center. And through the mobile unit modules, we are trying to give the capability to the physician, to the medical person, to embed, to, let's say, come up with, let's say, some specific questions, queries, to embed intelligence in the let's say, system. Okay, and in this way, through questioning, somebody can, let's say, use the. Somebody should, let's say, try to come up with an evaluation procedure of these queries that a medical person is posing to the, let's say, system. So the sensor capabilities and the modules, as we see, is composed by 4 subunits that are related to sensing, monitoring, communication, and data handling. And the mobile unit capabilities are linked with aggregation, communication, of course, and, let's say, handling of data. Now the rules are basically event and action oriented, so we are looking for helping the physician deal with, let's say, events like spontaneous events or persistent events, and of course actions. So, for example, here we used a mobile unit, let's say pocket type of PC. These are the prototype, let's say, implementation tools that, let's say, we used. Here are the MBU demo snapshots. Okay, so a physician can set up his own rules, okay, among others. And then these rules have to be more or less verified automatically at the end of the, let's say, sensors and at the end of the, let's say, medical center. And that's a snapshot, an MBU snapshot in the PDA used. And so this is more or less the work that we're doing at this moment. We are continuously upgrading this system. So we want, as we said, to support spontaneous and persistent events. We want to interconnect with the medical contact center via the service-oriented approach, and of course the security issues that are quite that are very, very important, of course, in this case. So if, let's say, we want to go to pHealth trends, the new trends are we are going towards closed-loop pHealth systems like the Heart Cycle project that has started just 2.5 months ago, more or less. And here we will be dealing with both patient and pro loops as well. It's a big consortium that is comprising both of let's say, medical sensor industries, research institutions, academia, and of course medical centers. And finally, I think that one of the issues that, some of the issues we need to address are the interoperability and the standardization of the pHealth systems. So we need to discuss about adoption of let's say, standards where available, like the biomedical signal encoding and the data, let's say, communication. I think that the biomedical signal encoding and the interoperability between the data that various sensors are taking is really a big problem at this moment. It has not been resolved yet, but I think it is up to the industry, to the medical device industry, to really come up with a specific solution. We have also to see the issue of semantic interoperability. That is another very important area. In other words, having good access to various sources of information and knowledge. And finally, the current trend is to go into the standardization of pHealth devices and services, like the Continuum Alliance or the HL7 messaging for integration with the electronic health record, for, let's say, example. So in my view, in this case, we have to come up with a more global umbrella under the area of, let's say, pHealth that will, let's say, help support these actions. And finally, I would like to present for the first time the call for papers that you are the first audience to see it, okay? Of course, a number of these, all these, this call will be available in the future months in the IEEE webpage and, of course, in the Transactions for Information Technology in Biomedicine. So we have the special issue on personal health systems, for the transactions on ITB. The submission deadline is for January 15, 2009, so there is time, but so I think that we have quite a lot of, let's say, mature material, both from the sensors developers, from the intelligent systems for the, let's say, standardization and so on. And the idea is to try to have the, let's say, publication in 2009. And after discussing, of course, with the outgoing editor-in-chief Nilos Aranoumi and the incoming editor-in-chief Y.T. Zhang, the suggestion was, let's say, to have 3 editors in 3 different continents so that we can try to get the most out of the personal health systems that, let's say, are developed, for example, in Europe, in Asia, in the, let's say, Americas. So it is myself, Toshio Tamura, and Paolo Bonato. And you are all, of course, invited to submit your research and your work into this special issue, or special issues, I don't know how many papers we will get, so that we have a good grasp of what is happening in the PHS systems. And that's it. I'm done. Thank you very much.